Begin with a sound that should not exist. In November 1969, a spent spacecraft stage slammed into the moon at highway speed and the moon sang. Not a song you could hear with ears. A low, stubborn vibration, reading across seismographs like a bell a giant forgot to muffle.
Minutes passed. Then an hour.
The echoes didn't die the way rock is supposed to swallow its shivers. They rolled and lingered like a cathedral's last note, stretched thin across a vacuum that should have ended everything quickly. In the control rooms and the quiet offices where scientists pretend nothing ever surprises them, people leaned closer to the paper and the ink and asked a question that felt like a trap. Why does a stone behave like a drum?
You can explain some of it.
The moon is dry as old bone. It is cracked from impact after impact, welded in places by ancient fire, and empty of water that might help dampen motion. In physics, this is a high-quality factor, Q. A system that holds onto energy like a miser holds onto coins. But explanations are not shields. They don't stop the feeling that something basic has been missed. A solid sphere is supposed to gulp and forget. This one remembers. It is the kind of behavioral glitch that makes engineers frown and poets laugh. It is also where a certain family of ideas takes its first breath: hollow places, hidden shapes, interiors that don't match our models. Theories crawl out of the dark and stretch, asking to be considered, however briefly. The moon rang like a bell. You can shrug or you can listen. Set the sound aside for a moment and look at the geometry. The moon's orbit is nearly a perfect circle around Earth. It rotates once per circuit, locking one face toward us forever. And when the moon steps in front of the sun, it covers it with an audacity that feels choreographed. The disk fits the disk. The solar corona unfurls like white fire around a black coin. The numbers are rude in their neatness. The sun is about 400 times larger than the moon. The moon is about 400 times closer to us than the sun. From here, they match, as if someone with a pencil and a ruler had a say. Isaac Asimov, who loved puzzles enough to write about them for a lifetime, pointed to that coincidence and raised an eyebrow. Nature deals in abundance and variance, not in perfect masks. Eclipses that exact are not impossible, but they are theatrical. Add the whispers you can measure to the ones you can't. Tidal forces yoke our oceans to the moon's pull. Without that companion's weight and rhythm, Earth's tilt might wobble and wander, seasons might lurch, climate might swing between moods too wildly for complex life to find its balance.
The moon keeps our planet's axis steady enough to vritte calendars. It steers the shorelines.
It choreographs the biochemistry of spawning and migration in ways we catalog and still don't fully grasp. The story runs backwards with a shiver. Without this exact neighbor in this exact place, for this exact long stretch of time, would a species like ours have ever had time to stand up, look out, and ask why the ocean shines at night? Now go back to the machines on the moon. Apollo left seismometers in the dust, and those instruments kept listening long after the flags drooped and the footprints hardened. They heard quakes that lasted too long and rolled too smoothly. They heard internal murmurs that refused to behave like the fractal chaos we know from Earth with its water-slicked faults and hot core. They heard a world that answers in a tone we can't yet hum. This is where you stand at a fork. On one path is the comfort of known mechanisms pushed to unfamiliar extremes. Dry rock, high Q, fractured mantle, a crust that rings because it is brittle and old. On the other path is a question you are not required to ask but cannot fully avoid. What would it mean if the moon's interior doesn't just surprise? What would it mean if it was arranged? People have asked that and worse. In the 1970s, two Soviet researchers put forward a hypothesis that sounded like a dare. What if the moon is not entirely natural? What if its shell is reinforced, its cavities designed, its orbit placed? Their paper was ridiculed and then shelved without ceremony, as most heresies are, but it never truly vanished. It lingers because the standard narratives, as rich and honest as they are, still leave seams we can feel with our fingertips. The giant impact hypothesis says a Mars-sized body, Theia, rammed early Earth. Debris glowed, cooled, condensed, and the moon was born.
Elegant. Powerful.
It explains the moon's dearth of volatiles and its similarity to Earth's mantle. But even here, puzzles persist. Isotopic fingerprints are almost too alike, suggesting a mixing so thorough it strains the models. Some crater floors are broad and shallow as if an invisible hand beneath resisted the blow. The moon is missing a large iron core, yet acts heavier in places than uniform rock should. The story fits until it doesn't, and the leftover scraps keep twitching. In laboratories and on screens, we run simulations by the thousands. We vary impact angles and speeds. We spin the proto-Earth faster or slower. We seed the debris disk with different particle sizes and watch moons accrete like slow snowballs. To land where our moon sits, with this tidy orbit and this remarkable lock, the parameters have to dance on a narrow stage. You could say we were lucky. You could also say we were selected. That word makes people itch. It smells like intent, and intent suggests a mind, and a mind beyond ours does not sit comfortably at many tables. But selection need not be mystical. It can be practical. Maybe only worlds with a moon like this stabilize long enough for noticing to evolve. If that's true, the moon is not a gift. It is an admission ticket. There is a ghost story that attaches itself to Apollo every time someone wants to spice the stew, and it goes like this. During the first lunar landing, communications broke for 2 minutes. In those minutes, whispers say, Neil Armstrong used a reserve channel to report watchers on the ridge. They're here. They're watching us. The rumor persists because rumors feed on appetite, not on evidence. Ham radio operators claim to have heard it. NASA denies it.
No proof survives.
You can roll your eyes or you can understand the hunger that makes myths grow teeth. We prefer our mysteries to have faces. We like to imagine an audience looking back. There are, however, anomalies that don't require shadowy scripts. Before and after Apollo, observers recorded brief, localized lunar glows. Transient lunar phenomena, they were called in polite reports. Aristarchus crater, bright as frost, flared and dimmed in minutes. Red tints bloomed where none should be. Gas release from the deep? Solar particles tickling dust into plasma? Eyes playing tricks at the edge of dusk? Explanations line up and none claim the field. Small facts like these are not proof of wild anything. They are reminders to keep the door unlocked. The catalogue of lunar oddities has been padded with claims that range from sincere to spectacular. George Leonard, once a NASA analyst, published a book insisting that enormous structures appeared in Apollo photos towers, domes, something like roads. He accused the agency of cropping truth into shadows. The images he cited were low resolution. The shapes he adored were the kind pattern-hungry brains draw on clouds. Later missions with better cameras did not confirm city skylines among the craters, but they did find lava tubes wide enough to house cities, skylights that open into kilometers of airy basalt caverns. Nature builds spaces fit for habitation, even when we're not invited. Somewhere in there is a lesson about the line between desire and data. It isn't only Western myth that lifts its head when the moon is mentioned. Ancient cultures archived whispers of a time without a moon. Some Greek sources speak of the people before the moon. A few American indigenous traditions, some Sumerian echoes, stories told around fires under skies that remembered different patterns.
Myths are not minutes. They don't timestamp events.
They keep emotional truths more faithfully than physical ones. Still, they carry smoke from old fires. Can you hold both things? That human memory is unreliable, and that human memory sometimes points to real scars? While we argue and imagine, a simple drift continues.
The moon is leaving.
3.8 centimeters a year on average.
A slow, tidal dance.
Energy slides from Earth's spin into the moon's orbital momentum, and the moon uses it to step away. Long ago, the moon was closer, and tides were more violent and more frequent. They scoured shorelines where life could concentrate chemicals, mix them, bake them, wash them, again and again. It is not crazy to think that tidal basins became chemistry's first theaters. In the far future, the moon will be far enough that total eclipses fade into annular rings, coronas without closure.
The best seats are now.
We are a species that woke up between two windows and learned to love what we saw. The other numbers matter too. Helium-3, a light isotope that fusion designers dream about, dusts the moon's skin, planted over billions of dawns by solar wind.
Some claim abundance.
Caution says the layer is shallow, the extraction costly, but possibilities don't crumble just because they are difficult. The moon's farside crust is thicker than the nearsides. The nearsides Maria are basalt seas, poured from deep wounds. The far side is more mountainous, more pockmarked. Why the imbalance?
Yearly Erzheat?
Asymmetric bombardment? Coincidence that refuses to stay random? When the first Apollo stage hit and the seismograph sang, people suggested repeating the experiment at different spots to map the moon's interior like a bell maker taps a bronze.
NASA did.
Different impacts, different distances, different durations. The patterns let geophysicists infer layers, densities, a small core with a taste of iron, a mantle with a surprising stiffness. It did not solve the puzzle completely. It also did not confirm a metal shell or a smooth void large enough to swallow a city's worth of sound. The truth remains hilariously stubborn, nuanced, partial, a spectrum of maybes instead of a single headline. Remember Zond 3, a Soviet probe that in the mid-1960s photographed the moon's far side with admirable sharpness for its era. In some frames, enthusiasts later claimed, a needle rose, 2 kilometers tall, a tower where none should be. Later missions did not find it. Artifacts are as loyal to cameras as truth is. And yet, human eyes keep searching for lines that right angles might draw. Clementine, a 1994 joint mission, mapped the moon in multiple wavelengths. It too became fuel for 1,000 YouTube narrations that found cylinders in shadows and domes in compression artifacts. Somewhere between paranoia and poetry are the facts. Sunlight plays hard games with low-angle light, and our brains are conspirators in making sense, even when there is none. The Apollo era ends in 1972 for public money reasons, not because the moon got smaller.
Budgets thinned.
Wars chose their appetites and fed them. Scientists kept wanting. Engineers aged into stories. Decades later, Artemis promises a return, not as a set of flags and footsteps, but as an infrastructure plan. Gateways. Landers. Base camps on the rim of polar craters where the sun schemes the horizon and ice hides in the permanent shade. There is an irony when you notice it. To read the moon's secrets with any real fidelity, we have to treat it less like a mystery and more like a workplace. We need seismometer arrays with modern ears. We need heat probes that can bite meters deep. We need gravimeters in swarms and reflectors that let us time the moon's distance to a millimeter. We need robots that crawl into lava tubes and sniff for chemistry that has not been tasted since lunar seas were hot. Imagine a mission that repeats the Bell test, but with intent. Several small impactors, each with known mass and velocity, strike sites chosen to triangulate the interior. A web of sensors hears the notes, and algorithms reconstruct the voids and the densities the way an MRI assembles images from signals. We would learn how thick the crust is not just on average but around the rims and the floors we argue about. We would test whether some Maria hide layers that ring differently, whether the far side's depth carry surprises. We could strip the moon politely of its last excuse to be coy. The skeptic in you deserves a chair at this table. They say, a high Q resonance in dry, fractured rock can last long because nothing inside is wet, hot, or convective enough to eat the energy fast. They say, the eclipse neatness is temporary and accident dressed nicely. Over cosmic time, the angular sizes fight and flirt. Today's magic is tomorrow's math. They say, shallow craters could be shock behavior in layered basalt, not steel plates under dunes. They say, helium-3 is interesting for papers, not for power yet. They say, myths are not minutes. And then, if they are honest, they say, but we haven't done the work at the scale that would put these to bed. Skepticism isn't a stop sign. It's a speed limit. It keeps you from flying blindly. It does not forbid travel. There is another kind of silence to acknowledge. After the moon, public space programs looked outward. Mars became a mirror we could imagine walking into. The outer planets offered storms and rings and moons that are small universes in their own right. The moon, our close neighbor, became a place we knew too well to court. But proximity is not familiarity. Beneath a regolith as fine as smoke are layers written with impacts, lava, and time. We've tasted grams of rock. We've mapped from orbit. We have not bored into the old flows to see how long they cooled, layer by layer. We have not positioned an array of detectors in the right spans to catch a deep moonquake from multiple angles and solve the interior the way sound solves submarines. We have not done the boring, which is to say we have not done the essential. Now return to the more dangerous idea. If the moon was placed, by whom and for what? A sentinel to watch or warn? An ark to preserve something alive or something else entirely? A stabilizer by design, because stable climates make stable projects? These questions entertain and scare because they hand you a universe with plans. The cleanest thing to do is file them under fiction and sleep well. But there's a subtler path that respects both the scientific discipline you owe reality and the imaginative courage you owe yourself. Let the design hypothesis live as a thought experiment with rules. What observations would it predict that geology would not? Uniform shell thickness beyond what cooling dynamics suggest? Residual magnetization patterns that act like former coils? Unnatural alloys in subsurface pockets with electrolytic histories that cannot be explained by meteoritic contamination? If you cannot name tests, you do not have a hypothesis. You have a mood. There are tests. We can do them. Place magnetometers in a global web, Measure the moon's current whisper of a magnetic field with more precision than anyone has cared to until now. Look for the fingerprints of ancient dynamos that refuse to die. Drill down into lava tubes and scrape layers that in no model formed in a vacuum without something else at work. Use gravimetry not only for pretty colored maps but as a tomographic method to detect shapes that stubbornly hold symmetry where randomness should rule. Send a mass spectrometer into a skylight and sniff the staled breath of trapped gases. If design is there, it will bleed in the data. If it's not, the moon will still tell you stories you have never heard. You can also ask the question nobody wants to spell out: if someone built, are they still building? If someone placed, are they still present? The mature way to ask that is not to paste grids on photos and scream at smudges. It is to look for signatures of activity that physics would recognize: waste heat where geology predicts none, periodic emissions of gas or plasma with chemical ratios that scream industrial, not volcanic, patterns in transient lunar phenomena that match engineered processes rather than random exhalations. The probability is low. The cost to peak is not absurd. The prize is either a new science of dead worlds or the first email we will ever receive, written in stone and light. Let the mind step away from the lab and walk into human rooms. A sailor long ago used the moon to know where he was. A farmer watched its phases and knew when to plant. A parent told a child a story under its glow and named the shapes on its face as rabbits or men. Poets leaned on it when they had to speak about longing without getting sticky. The moon is not only a physics problem. It is a cultural organ. If we go back with machines and numbers and stay long enough to become neighbors, our myths will change. They will not get smaller. They will get clearer. The story shifts from what is that to what is that to us. Artemis speaks the language of permanence: repeatable access, supply lines, cabins where dust coats your boots in the morning, and the horizon runs in a circle that never ends. On that horizon are craters where the sun never rises. In their floors sleep ices that form tapestries of hydrogen and oxygen, maybe ancient organics, maybe the kind of carbon that knows tricks. Extracting is chemistry.
Surviving is engineering.
Thriving is art. A base that lives on the rim of a crater will need a relationship with darkness and cold that borders on love.
The instruments we place will listen for ears.
They will gather the moon's long breath and, if we are lucky, catch one more ringing echo from an impact we plan and a world that answers. It is easy to be cynical. It is easy to look at grand plans and smell politics or profit. Space does not get a free pass because it is big. But some projects justify themselves by expanding the radius of what counts as us.
The moon is one.
If we learn that it is exactly what geology says it is, plus some quirks, we win. If we learn that it is stranger and we didn't notice because we were busy, we win differently. If we learn that it was placed, that someone with a patience longer than winter set it there, we do not just win.
We wake.
Please step carefully among the American legends of blackout minutes and secret transmissions. Please also notice that not everything is a legend. Buzz Aldrin did report seeing a light that he could not identify during Apollo 11's journey. The crew considered hardware as the source. Later, likely explanations were offered. The honest word in that sentence remains likely. In other missions, odd radio glitches occurred. Cameras caught glints that arguments later pierced and folded into nothing. The right posture toward all of this is neither worship nor contempt. It is curiosity with a long spine. The moon's receding walk has implications you can feel. Total eclipses are theater we borrowed. They will leave the bill on the table, and time will pay it. The tides we count on will turn a little gentler over geologic time, and the day will grow longer by fractions that add up to epochs. If you're the kind of animal that thinks in thousands of generations, these are the facts that weight your decisions. Do we become a species whose weather we can resist, whose food we can grow in machines and sunlight, whose stories do not require a coastline to feel at home? Or do we let the moon drift and the climate wander and write our epitaph on sand? The moon isn't choosing.
We are.
Listen to the engineers who talk about swarms. Not the sci-fi swarms that blot out suns, the modest ones. 100 nodes the size of shoeboxes, each a seismometer or a magnetometer or a gravimeter, each with a little brain and a little power and an ability to speak to its neighbors. Put them in a network across mares and highlands. Add a handful that rappel into skylights with lines woven from materials that fear nothing. Strap sensors to the roof of a lava tube and measure how the cave breathes with days and quakes. Make the moon an instrument. Stop treating it like a museum. Then run the experiment the mind fears. Announce publicly the criteria for artificiality you will accept. Not blurry towers. Not domes that vanish when you zoom. Make the bar high and the language clear. Invite skeptics to help write it.
Set thresholds.
If waste heat above X, sustained for Y at location Z, and no geological driver plausible, then publish and ask for the world. If emission series with pattern A at crater B repeats with interval C and responds to no solar cycle, then hypothesize. This is how you keep your integrity when you walk near the edge of wild. You cannot untangle the moon from us. We named it seas when we knew nothing of their dry basalt hearts. Sea of tranquility.
Sea of showers. Sea of rains.
Mare Imbrium holds a ring like a bruise. We left a memorial there for astronauts and cosmonauts who died reaching. We put mirrors on the surface and ticked lasers off them so precisely we could watch the moon's retreat by millimeters and smile at our own competence. We left golf balls and family photographs and a small sculpture. These are not experiments. They are offerings. They say, we were here, we will be back, we are learning how to stay. Now imagine the future rumor you would like to be true because it is beautiful and possible. A crew on Artemis 5 deploys a new array. It catches a deep moonquake, not from impact but from something inside shifting like an old house in winter.
The signal is crisp.
The inversion yields a map with a feature nobody predicted, a lens-shaped zone at depth that transmits vibrations the way glass channels light. Is it a layer of unexpectedly dense basalt? Is it a structure? The papers argue.
The data multiplies.
No consensus arrives quickly, which is how you know it is real. While the scientists fight kindly, a rover enters a lava tube and finds mineral formations that would shame a Gothic architect. Layers of olivine and pyroxene glitter in the stark light. A rock that looks like a tool sits where no hand has been.
It is not.
It is a nod from geology to hubris. We laugh and keep going. There is a child watching all this in a classroom somewhere. They are not impressed by conspiracies. They are impressed by patience. They grow up and become the person in a room who says, softly, that we need to commit to 10 years of looking, not to 10 minutes of wonder. They design a sensor that hears what we didn't know we were missing. They fall in love with someone who finds the long timeline romantic. They go to the moon and stand at the edge of a crater and describe the sky as an inside-out bowl of black decorated with fire. They speak into a microphone and the world hears the steadiness in their voice and trusts that we are not sightseers anymore. You can make a list of what we do not know about the moon and treat it like a grocery list. How thick is the crust beneath the far side highlands? What is the true shape of the core, solid and liquid portions alike? How old are the youngest basalt flows in Oceanus Procellarum? How often do deep moonquakes occur and how do they couple to surface phenomena? What's the inventory of volatiles at the polar cold traps, and how do they stratify? Do we detect any trapped gases in lava tubes that speak of past flares or present leaks? What is the spectrum of helium, 3 dose across different regolith ages and depths, and what does that teach us about solar history? The nice part about this list is that every item on it has an experiment attached, and every experiment makes us better at being a species that does not guess when it can know. Another truth, even if secrets live in the rocks, the biggest secret the moon holds is us. Our taste for patterns. Our weakness for neatness. Our habit of treating wonder as either something to be worshipped or something to be mocked. We can do better than both. We can let the moon be strange without immediately ordering t-shirts declaring what that strangeness means. We can accept that some coincidences, like eclipses so perfect they break your heart, exist because the universe has room for beauty with no permission slip. Of course, if later, under skylight shadow and sensor hum, we find proof that something was built, the kind of proof that survives translation and microscope, the kind that is cruel to wishful thinking, then our stories change with a speed that will test our best selves. It will not kill religion.
It will not kill science.
It will force both to learn a new posture. Humility, but not the kind that makes you small. The kind that makes you responsible. There is a version of the future where we do all this and the moon answers in the oldest language of all, patience rewarded.
We map. We measure. We build.
We hear the second bell ring as planned and we see with numbers how the interior layers slide past one another like cards. We watch an eclipse from the moon's surface and the sun shrinks without atmosphere to turn it into a spectacle of shadows on hills that look like sculptures. We send a small boat of instruments to skim the exosphere and learn how a breath can be made of nothing and still matter. We stand at Shackleton's rim and watch an Earthrise that makes our chest ache. We go home not with proof of aliens, not with helium-3 for power plants, not with headlines that will mend an angry world in a week, but with the quiet certainty that we are competent and curious and kind enough to keep asking. There is also a version where we don't. We slime the timeline with budgets that cannot decide, we let arguments about refinery rights eat the soul out of the inquiry, we allow images to substitute for understanding. The moon recedes on schedule. Eclipses thin and become less mythical. Someone writes a book about the time we could have known and chose not to. It sells, and then it disappears like all books do, into shelves and memory. That ache you feel when you look up becomes a memory of an ache. Your grandchildren live their big lives and do not miss what they never had. It is not my job to sell you fear. It is not my job to sell you destiny. It is to remind you that every time the moon rises, something inside you rises too.
Call it curiosity.
Call it a compass that points up. The moon is not a conspiracy.
The moon is not a marketing plan. The moon is a neighbor.
It keeps its own hours. It minds some of our business whether we invite it to or not. It has been the metronome of our nights for as long as we have kept time. This next century, we get to decide if we will finally learn the song it's been tapping out, in frequencies that require machines, in patterns that require attention. Start again with that sound. The stages hit, the ground quivered, the seismographs whispered a word you can translate loosely as more.
More instruments. More patience.
More willingness to hold two ideas at once, that the simplest explanations deserve first dibs and that the greatest stories sometimes turn out to be true. When the bell rings, you can confuse your goosebumps for proof. Or you can take a breath and take a measurement. Look up tonight, if clouds permit. The bright plain you can see with your naked eye, Mare Imbrium, once was lava that pooled like night. The darker blotches are seas that never were. The light highlands are old, battered, proud. If you have binoculars, find the sharp-floored crater Tycho near the southern highlands. Rays of ejecta streak from it for thousands of kilometers, a splash frozen in stone. Imagine the energy that made that, the shock waves that rattled through the moon, the ring that would have rung then without a seismometer to know it. Imagine that sound crossing a vacuum not as noise but as knowledge waiting for someone like you to come and translate it. When you do, don't do it alone. The moon has always been a team sport. Sailors, farmers, priests, mathematicians, artists, astronauts, engineers. Bring them all. Ask the hard questions. What rocks do we need to sample, and how deep? What instruments will fail without spaceship-level care? What agreements must we sign so that a robot stepping into a cave does not become an argument about flags? What story should we tell children so their wonder is a tool, not a toy? The answers will not fit into a thread or a clip. They will fit into a lifetime. One last picture. A lab. Whiteboards. Coffee rings. On a screen, a series of curves, jagged and then smooth. A grad student points to a frequency peak and says, "There it is again." The professor rubs tired eyes and grins. They both know what it means and what it doesn't. They know there will be reviewers who will ask for more, and they will be right. They know there will be a talk where someone in the back says aliens under their breath and someone else smirks. They know that truth moves like the moon, away, then close, then away, in cycles that make you both patient and brave. They close the lab late and step outside.
The sky is cold and full.
The moon is there, neither closer nor farther than it is, lit like a coin you've held all your life and only now understand has two sides. One we know by heart. One we are finally ready to explore.